Okay, we've got a problem here from section 3.4 on optimization, which is just the general idea of trying to maximize or minimize some kind of function. So what they ask us to do, this is kind of a basic problem, a very good one to go through, just learning the techniques of optimization and how a lot of these are put together. But it's a problem just involving words and some mathematical concepts directly. And basically, to answer the question here, we're just going to kind of solve this using the problem steps for optimization, the guidelines for optimization in the book, which are on page 236. So first of all, let's read the sentence of the problem. The directions say, look for two positive numbers that satisfy the given requirements here. So here's what they tell us. The sum of the first and twice the second, okay, the first number and twice the second number, is 100, and the product is maximum. Okay, so when you read through the guidelines, they say kind of first of all, five steps to do these problems. First step is identify the quantities that you're trying to find. So really we're looking for two things, and generally when you're looking for two things, you want to give them each a name or a variable name. So what we're looking for is, so this is step number one of the problem, we're looking for two things. I'll call them x and y. X is the first number, okay, and y is the second number. Okay, so that's pretty good. Now, again, typically when we actually optimize a function, look for the maximum or minimum of a function, it only depends on one variable. Okay, but that's kind of what we're going to get into a little bit later. Basically, this problem asks us to find two things, a first number and a second number. Okay. Now, if you read through the guidelines, they say next, write a primary equation for the quantity that is to be maximized or minimized. Okay. So what we need is some kind of a function which we'd like to maximize or minimize. Okay, well, they say the product of these two numbers is maximum. So they're telling us, what is going to be maximized in this problem, the product of these two numbers. So you could say we're trying to take this thing p, the product, which is x times y, and maximize p. Okay, product, remember, just means multiply. So what can we do to find the two numbers, x and y, which maximize the product? So this is the thing we'd like to make maximum, p, the product. Okay. So that's the second step. Okay, already almost halfway through with it. Okay, well, the third step is to get what they call a secondary equation. And again, what we have here really isn't a function. I could say p depends on two variables, x and y. What we'd like to do is write this product that we're finding, in terms of just one of these variables. Okay. Now, how can the product of two numbers really just depend on one of those numbers? It seems kind of odd, but again, the third step here in the guidelines say reduce the primary equation to one having a single independent variable. Okay, right now this equation has two independent variables, x and y. We want to get rid of one of these, and they say that sometimes involves finding a secondary equation. Now, if you read our problem, there is some information there that we haven't used, and it has nothing to do with the product of these two numbers. It's the first sentence. Okay, they tell us that the sum of the first and twice the second number is 100. Okay, so what we'd like to do is write this as just a formula involving the product and one of these two variables. But what they've told us is that the variables actually relate in the following way. The first plus twice the second, so x plus 2y equals 100. Okay, so this is just an identity. This is information that they're supplying to you in addition to the thing we're trying to find. Now, if you think about the problem, find the biggest product you can of two positive numbers. Of course, there really isn't an answer there, and you just make both numbers as big as possible. Okay, but this extra thing, this thing they call the secondary equation, gives us a restriction on what x and y can be, because not only are these numbers positive, but the first plus twice the second has to be 100. Okay, now that's important. So what we can do here, and this is still in the third step, they want us to reduce this to an equation just involving one independent variable. P is the dependent variable, x and y are independents, using the secondary equation. Okay, and that's easy to do. In fact, if I just subtract the 2y over to the other side, I see that the secondary equation is really telling me x is equal to 100 minus 2y. Okay, now what that allows me to do is to rewrite the formula for p. Okay, p is x times y. Okay. So it's x times, it's y, let's write it this way. It's 100 minus 2y times y. Okay, what did I do here? I just replaced the x with what we solved for. Okay, See, the secondary equation is really what's helping me here. It's telling me that, in other words, x is 100 minus 2y. So what I did is I rewrote the formula for p, replacing the x with 100 minus 2y. Okay, that's what x